Okay, so welcome everyone. This is going to be the part 2 of the Introduction to Linux workshop. We're going to learn some really exciting things today. So Ariba, could you go to the Discord? Just a reminder, if you haven't joined our Discord channel yet, this is the Discord channel that we're going to use for all of the DSC events. We're going to post the link for the description, for the Discord in the chat. So join there if you have not. If you have already, open it up and it should look like this. Under workshops, there's a channel for Linux workshop. If you have any questions or anything, you can either post in here or in the Zoom chat. But what's really cool about this Discord server is that, when you are in like lectures or in workshops in real life, it's really common to like ask the person beside you, like, oh, what did she say? Like, or if you have a simple question that you don't want to ask everybody. We've tried to replicate that in some kind of way. So if you see here, it said code with buddies. Click to form groups. So you can click 2 people, 5 people, yeah. And then it'll create a new voice channel with just you in it, and people can come in and join. Also, we have the help room. This is a really important, I think, whenever you get stuck, say you have some error or something like specific to you that you can't figure out, you can click here for help, and see it makes a new channel with you in it, and it has your hand raised. So we have 3 awesome mentors, Shardul, Jay, and Bilal. They're available, and they're gonna, if they see your hand raised here, click here. When you said click here for help, they're gonna join, and then that you can actually like share your screen, and they can help you get caught up to speed and things like that. Yeah. So if you have any questions, like honestly, feel free to post anywhere and click here for help. This stuff is really exciting to learn, and we don't want anyone to fall behind. So yeah. I'm gonna pass it on to Ariba now, who's going to get started in this workshop. So welcome, Ariba. If you haven't already, or if you have a new GitHub account or something, then post the email there.
Okay, thanks, Miranda. Okay, so I'm Ariba. I'm the president of DSC McMaster U, and I'm in third year of software engineering at McMaster, and I will be doing the workshop series. So, like Miranda said, this is a two-part workshop. The first part was a very basic introduction of what Linux is, and it was an introduction to some basic commands in the terminal, and also an introduction to Git and basic Git commands. If you missed that workshop, we have it on our YouTube channel, and we will post our link on the Zoom chat or on Discord. So if you want to quickly recap on that, you can do so. And then today we will be having our intermediate Linux and Git workshop. We're going to be going over some more advanced commands. Also, we'll learn bash scripting, which is used a lot in the industry. We're learning something about file permissions, and then we'll learn about Git branches. So this is just a more detailed agenda. We don't have to go through all of it, but basically we're just going to do some introduction, and then I'll do a very brief recap from what you should have learned by the end of workshop 1. And then we'll go into the commands and bash scripting. We'll take a little bit of a break, and then we'll get into Git branching, and then we'll do a really long Git branching group exercise. So to really help you practice using Git and Git branches, and then you'll probably run into some issues, so we can help you troubleshoot those issues. Okay, so the prerequisites and setup. One of the prerequisites is to have watched that video, but if you haven't so far, that's fine. We will be doing a very, very quick recap of what you should have gotten from that workshop in a bit. And then if you haven't already, have some Unix command line interface ready. So if you remember, if you're on terminal, if you're on Mac OS or Linux, you just search terminal and you open that up. So this will be your terminal. Or if you're on Windows, you can use the Windows subsystem for Linux or WSL. You also need a GitHub account, and you need Git installed. And as a quick recap, to check whether Git is installed in your terminal, you just do git --version, And then if you get something like this, that means you are good to go. If you don't get something like this, or you are having issues opening your terminal, then you should hop on to one of the voice chats on Discord or message one of the mentors on um, the Zoom chat, and then we will help you get that set up. The other thing that you need to do is once you on the Discord channel, once you send your email on the Linux workshop, we will add you to the GitHub repo that we will be collaborating with. This is the same repo that we worked from the last workshop. So if you're already in it, or if you already collaborated on this repository, then you don't need to do anything. But if you haven't, then please send us your email and we will add you as a collaborator. And then you need to go to your email and find the email from GitHub that says this. DSC McMaster is inviting you to this workshop, and then you need to accept that. So once you have all this set up, you are ready to go for the rest of the workshop. And again, if you don't have any of these set up, please ask one of our mentors and we will get back to you. Okay, so now I'm just going to do a very quick recap of the workshop from the last workshop. So what we're going to do is go on our terminal, and I'm just going to go to a temporary directory on my computer. But what you can do is just create any directory that you want by using the mkdir command, and you can create any directory you want. I'm going to create a directory in my /tmp/workshop folder, and I think I already created this before, so I'm just going to call it Linux Workshop. And then I'm going to cd into that directory by using cd and then this shortcut. Now I'm in this directory. And then as a recap, to check what items are in my directory, I do the ls-l command. So far what we talked about was mkdir to make a directory, cd to go into a directory, ls-l to see what items are in your directory. And then we will also use a command called touch to create a new file in your directory. So this creates a file. And then the other command that to add like one line to this file, we just do the sentence that you want to enter, and then you direct the output with this angle and bracket to the file name. And then so this gets sent to this file. So to read what's in that file, you use the command called cat. And to edit this file in an actual text editor, you can use nano and then the file name. This will open up this text editor. So you can edit this file as however you want. To save this on nano, you have to do Control O, enter, and Control X. I did it. Okay, yeah, Control O, enter, and Control X. So that's using nano. So those are the main commands that we learned last time. Okay, so those were the terminal commands that are used for like getting around directories. The other thing that we learned in last workshop was the copy command. So to copy a file, so that's the cp command. So you take cp and then the original file that you got, and then the file that you want to copy it to. And then now you have a file that's the same as the first file, and they have the same content. And then the other command we learned was the move command, which is also the same command that's used for changing the name of the file. So what we do is write mv and then the original name and then the name that we want to change it to. And now we've changed the name. And the other command that we learned was making the directory, which we already did right now. So this is to make the directory. So those were the commands that we learned last time, and we learned some basic Git commands too, but we can go over that in a bit. Okay, so now I'm going to go over some other commands for this tutorial. Okay, so now we're going to get to the content of this workshop. So what I'm going to do just to start, I'm gonna just delete everything in this directory just because I want a fresh plate. So now I have nothing in my directory. Now we're gonna learn about file permissions. So what we're gonna do is create a file. We'll just call it file. That's confusing. We'll just call it file, my file, and then we do ls-l. So if you notice that when you do ls-l, you get this stuff over here. And what this stuff tells you are the permissions for this file. So we will figure out what these means. So the first 3 bits over here are the permissions that you have. So what account that you're logged into. So to check what user you are, you can do who am I, and then it will tell you what user you're currently logged in as. And so right now I'm logged in as the user Ariba. And so the first three, let's ignore the first one. The very first character tells you what type of file that is. And if it's a dash, it's just a file. And the next three, these 3 characters tell you the permission levels for you as a user. The second set of 3 tell you the permission levels of the group. So which group you're in, because yeah, so I'm in my username in my computer is Ariba and my group is also Ariba, so that's why my user and group are the same. But sometimes you'll have like your username is Ariba but your group name is students. If you're working on a server on your school, it might be like students over here or something. So that would be your group. And then the last 3 are the world. So with the world, they just mean like whatever has access to this computer. And this is just anyone from any group in this computer system. So it might not make sense right now because you're the only one that uses this computer. But this is it's like when you're like for your school servers and when they're connected in a network of like school computers and stuff, it makes more sense because then in that case when you're logged into your school account, only your permissions are determined by this stuff, and then these 3 are like your students or your staff group, and then this is just like everyone. And yeah, so that is that. And then the what the 3 bits mean, r means read. So if there's an r over here, this means that I have the read permission of this file. And r is also in the group and the world. That means that me and the group and the world, we all have read permission, so everyone can read this file. um, W means write, so that means that I have write permissions, but the group doesn't have write permissions and the world doesn't have write permissions. That means that in this file, only I can access it from this whole computer. So if I log in as another user, I can read this file, but I can't write that file if I'm another user. And then the last one, which I don't have the permission for, is execute, which means that you can execute this file as a script or like as a program. But this one is just a dash. That means that I can't run this file as like a program or a process. And I'll explain how to make it executable later, but for now, it's just this. And so in your jobs or your co-op, sometimes you'll need to change the file permissions, but mainly, like from my experience, I mainly use this for making something executable. But to change the file permissions, there's a command called chmod. I don't know how it's pronounced, but I just pronounce it chmod. Um, and then so it's chmod, and then you have to enter some stuff here that I will explain later, and then the file name that you want to change the permissions for. And over here, what you can do is, so there are a lot of different ways to specify the permissions of a file. And one way is putting, so U for user and then plus X, or let's do read, right? So what this does, U plus RW, the stuff on the left side means what you're giving permission to, so user, group, or world. So U is for user. And then plus means I'm adding these permissions. And RW means the read and write permissions. So this means this all together means that I'm adding the read and write permissions to the user, just me. And now if I do this, it's not going to change anything because I already have the read write permission. But if I did G plus rw, what this would do is add the read write permission to group. So this would become rw slash. So now this is rw slash. And now that means that other people, other users in the same group as me can also write to this file. And then you can do the same thing for world. Um, so that's one way of changing the file. Something else you can do if you want to remove the write file for the group, you can do the minus sign instead of the plus. So then you would do g minus w, and what this does is it takes it removes the write permission for the group. And now you can see it's back to what it was before. So can someone tell me what I would need to enter if I wanted to remove the read permission for the group? Do you guys want to say it? All right, so it's g minus r, and that would remove the read permission for the group. And now that means that people in my group that are not me can't even read the file. So I'm just going to add that permission back. Okay, so those are basic file permissions. Another way you can add, you can change file permissions is by using 3 numbers. So if you notice that each of these three, so these you can think of each of these 3 as bits, and this is like if you know what you call it, bits and binary numbers, then this makes more sense. But it's like you have user, group, and wx world. And so remember, if I put as hashtag, then that means it's just ignoring this line. It's just a comment. So I just wanted to write the 3 stuff again. And what we want to do is basically, if I want to make, if, let's say I want to make the file permissions look like this. Like I want me to have all the 3 permissions, right? And then for the group, I want the group to just have read permission, and I don't want it to have write permission, and I want it to have execute permission for the group. And then for the world, let's say I don't want it to have read permission, I don't want it to have write permission, but I want it to have execute permission. So these are, so again, so this part corresponds to the user permissions, this one corresponds to the group, and this one corresponds to the world. And 111 means like 1 means you have that permission and 0 means you don't. So this means that the user has all 3 permissions. This means the group has only read and execute, and this means the world only has execute. So now to translate that into this command, all we had to do is take each of these groups and convert that into a number. So I'm not sure how many of you know binary, but you can just even look at it on like a calculator on your computer. I don't even know how to use calculator on my computer, but if you just Google like convert 111 to here, yeah, okay. So in your calculator, in your computer, I don't even know how to do it, but just Google like how to convert 111 to decimal. But 111 is 7, and then 101 is, so 1 2 4, so it's 5. And yeah, again, we're not going to go into like how I converted this. You can just like Google it for now. But right now, this binary number corresponds to a 7 in decimal. 1 2 4, this corresponds to a 5 in decimal, and this just corresponds to a 1. So this is a number that I'm going to use, and then I'm going to put my file here. And now when we press ls-l, it's going to show us the files that we did. So it's going to do 111 for the first group, and then 101 for the second group, and then 001 for the third one. So that's the other way to change files. A lot of the times, one common thing is like chmod 666 my file. So that's like if you want your user, everyone to just read and write that file, then it would be 666. If you want everyone to read, write, and if you want everyone to have all the permissions, then it's 777. That's the most permissions that you can give. Um, yeah. So that is that. And then if I just want to make it go back to normal, that's 6. And then that's 4 4, and then it should go back to normal. Okay. Um, I'll write the commands like later. 4 is a normal one. Okay, so now we're gonna learn about how to execute this file and what that kind of means. So what we're gonna do is open up Nano or Vim. I'll open up Nano so you guys can know what I'm doing. So I'm opening up that file on Nano and I'm just gonna type in echo and then hello world, and then that's it. So this is a very simple bash script. And a bash script is basically like what the commands that you write in terminal. You know how you write them like one by one and you press enter. So instead of doing that, you just take all the commands that you would enter and put it into a file, and then that's a bash script. And then you can run that script all together at once. Oh my god, I'm using Vim exit stuff. Control O, enter, Control X. Okay, so now that we have this file, so to run this file in Bash, so remember in Bash, in Bash, when you enter something like hello world, you get this, right? And right now I'm just writing it in my terminal, but all of these commands that I wrote and all of these commands that I ever wrote over here, they're not just like commands, they're actually in using like the Bash language. It's like a programming language. And to know what language you are actually running in the terminal, if you do echo and then $0, this is the program I'm running. It's bin bash. For you, it might be bin bash, it might be XSH, like XSH, or it might be SH, which is all fine too. They're close enough, so that's fine too. But yeah, bash is one of them that I like. And they're basically just programming languages. And if any of you have used Python, like the IDE in Python, um, remember when you use Python, it looks like this, and then you enter some stuff like 4 + 5, blah blah blah. So the terminal, the command line is literally just an interface for the Bash or your language, Bash or shell language. And so instead of like typing all these commands one by one, you can take all these commands and put it into one file, and then have your terminal execute all those commands in the file at once. And that's the concept of a bash script. Okay, so now we have this file that has this one command, and now we want to execute it. So to execute it, what we're going to do first is write bash and then my file, and then it's just going to run that file. So it was just bash and then my file, hello world. And if you're having issues with this thing, it might be because you're not using bash as your language. In that case, you can try sh my file, or you can do echo this 0 and then just copy and paste what it executes here, and then my file here. So again, you can just take whatever the output here of this was and then put that here and then execute it like that. Okay, so that's like one way to execute bash script, but in the real world, like you're not gonna write bash and then you're not gonna write bash all the time and write files. You're gonna want to just execute it like this. This is how you would actually execute like scripts. But the problem with this is that you get a permission denied error, and it's not just a sudo thing. So even if you do sudo, for those of you who don't know what sudo means, it means sudo is like it's just doing this command, but with like ultimate root permissions. So if you see this permission denied error and you think that's because you're not using sudo, even if you try using do sudo, you're still gonna get an error, because this is a permission denied. It's not like, yeah, it's a different permission denied error, because you don't have the execute permission. So again, what we did was my file here, like dot and then slash my file. And whenever you do something like this, like dot slash and then something, that's kind of saying like you want to execute this file, except you can't execute it because when you look at the permissions over here, there's no X anywhere. So you don't have the execute permission, so you can't execute this file. So what you need to do is change the permissions of that file to be able to execute it. So one way you can do that is add the X permission to your user. So if you do u plus X, that will add the execute permission to your user, and then you do my file, and now you have the execute permission. And you'll notice, if depending on your terminal, you'll notice that it might be a different color. For me, executables are a different color, so now it turned green, whereas before it wasn't green, it was just a normal white color. So when it's green for me and when it has the X over here, it means I can execute it. And now when I do it my file, it's going to actually run. So yeah. Um, and then if you want like also your group to have this file as well, and the world, I think it's this. Oh, it's other. It's not world. It's other. The last three things are other. So the O, you have to use O for that. So if you do ugo plus x and then you do ls-l, now all of the user and the world and everyone has executable from permission, so everyone can run this.
Well, hey, Ariba, I just had a question. What would be an example of other then?
Oh, other, okay, so for example, let's say you're in a school environment, like a school's computer network system, and so there are groups like students, staff, and admin, and then students would be like in the part of the group, but then other is like everyone, the whole world, but it's like admin. But yeah, I think other is like everyone, right?
Like people who are not in groups?
It's everyone, literally.
Yeah, yeah,
Yeah.
it's everyone, because when you do the group one, when these permissions are specific to the group that you're in. So if I see RX here, that means that these permissions are in my group. But if I switch to another group, then it might not show RX because the permissions for that group might be different. But the
Okay.
other for everyone is the same because that's like the same for everyone.
Okay, I see.
Okay, yeah, yeah. Okay, so now the last thing on this little exercise that I wanted to show you. I wanted to talk to you about the path environment variables. So in your Unix shell, you have environment variables, which basically means just variables that are stored in this session. So one popular environment variable is the path variable. So if you do echo and then dollar sign all caps path, it's going to show you a bunch of stuff. So this is your path environment variable, which I'll explain in a bit. But if you do the command printf and you enter, so the command was printf, then you'll see all of the environment variables that are stored in this session. And so there's a bunch of stuff that mean nothing. I mean, that means something to other things, but you won't really care about it. So for example, your username is over here. Um, your power your home directory is here too. There's some other your shell. This is like your programming language that you use. If I change that, it would be a different one, I think. But yeah, there's just some environment variables. The important one is path, because what path does is it basically tells the terminal where to look for executable files from. So here, let me just minimize this actually. So in this environment variable path, I have all these folders, right? It's all these folders, and then these directories are separated by a colon. So all these colons are separate directories. And what this basically tells the terminal is every time I enter any command, no matter what command is, like any command here, echo, cat, or anything, is going to look through the directories in my path environment variable, and it's going to find an executable file with that name. So if it can't find an executable file with that command name, then it's going to say, like if I just enter this, then it's going to say command not found because I tried to look for it in the path. So what we're going to do is, you notice that our new command or executable file we named is called my file. I had to do // to run it. But if I try just doing without // it's going to give me an error and it's going to say command not found. And the reason for that is because this directory that we're in, temp Linux workshop, is not stored in the path variable. Even though we're in the same directory of this file, if you don't put any // if you just do this, it doesn't look at the current directory. It just looks at whatever's in the path variable. So that's why when we ran the command, we have to do // because then it's specifying that we're looking in this directory that we're currently in. So to actually make this file executable from everywhere, what we can do is um, we can basically add this directory. So to see what directory we're on, you do pwd, and then this is a directory that we're on. And what we're gonna do is add it to our environment a path variable. So to do that, we do export. To add something to your path, you can do just hold on. Yeah. So what you can do is export means whatever you do export in, it's going to save this variable to an environment variable. So now I just create a variable called a, and now if I do echo $a, it's going to print whatever I just saved to it. And in bash you have to be careful of the spaces. You actually can't have a space between or after the equal sign. I mean, you can, but it's going to create some weird errors. Oh yeah, so it's best to not have any space before and after the equal sign when you're assigning variables in bash. So what we're gonna do is here, we're gonna take we're gonna like assign a variable path, and we're gonna give it the value of the current path. So if we put everything in quotation marks, I always like to put everything in double quotation marks all the time when I'm assigning variables, just to be safe, because bash can get really weird with strings. So to be safe, always put double quotation marks between everything that you're assigning, like whenever you're assigning variables. And then you have the dollar sign and path. So this part of the code, oops, this part over here, it just takes what's currently in your path environment variable and pastes it over here. Like it just takes that value. And then this colon is just like, it's just any arbitrary thing that we add. And we want to add a colon because in the path, we're supposed to divide directories by colon. And then, so this tick over here, what this does is anything in between these ticks is like a command that you can execute. So this tick and this tick, so this is actually going to execute the pwd command, and then the result of that command is going to put it over here. So I'm going to test this out with like a random another variable like test variable, and then if I echoed this, you can see in the end it added temp and then Linux Workshop. So it added the current path and then a colon and then the result of the command pwd. And you have to make sure you have the ticks around the pwd. And then this was the result. So now that we have that, we're going to um, assign that to our actual path environment variable. And also don't be afraid of messing this up, because even if you mess up the path, and even if you set the path to like some random variable value and you think you messed up, it's only saved to this current shell session. So if you open a new terminal, then it's not going to be saved. So if I do export path here and now I do echo path, this is what I get. And I got it twice because I think I entered this twice, so that's why I just got it twice, but that's fine. But I got this here, but if I'm on another terminal, if I open another terminal and I enter echo path, it's not going to have that anymore, because um, the environment variables are only specific to your current shell session. So when you close, so whenever you save environment variables, they're only saved in the current shell session, and there's no way that you can save them permanently except if you do something else, but we can talk about that later. But um so yeah, so don't worry if you mess up the environment variables, you can just close it and create a new shell. Okay, so now that we have path all set up, now if we do my file, it's going to execute. And this is cool because now you can go to like any directory and then you can just do my file, and now you're executing the file that you just created. And this is, you just created your first bash script. And our bash script right now is kind of useless, but what you can do with this like information, you can do really cool things. You can create like your own like shortcuts or short script commands. um I do that for myself sometimes. Like usually when I'm doing some code, I like to script a lot of the repetitive things that I'm doing, especially for like setting up the code base in the beginning. You have to set up a bunch of folders and set up environments and everything, and it's a lot of the things that we do is repetitive, so it's easy to just make a simple script and then either make it into an executable file and save it into your path, or save it into a folder and just run the executable file. So yeah, it's just cool because now I can just run it everywhere and it's the same thing. But then you just have to be careful because if I open a new terminal, and if I do my file, it's not going to work anymore. And yeah, so then you would have to do that whole thing again, export path to the directory. But let's say you wanted to make this like a permanent change, like you want my file to be a command, I mean a script that you can run anytime. What you need to do to make the environment variable permanent is you have to edit a file called bashrc, and this might be different depending on what operating system you're using. It's either bashrc, or if you're on Mac OS, it's probably bash profile. So if you're on Mac OS, you have to use the um, nano. So Mac OS people have to do nano and then squiggly sign slash dot bash profile, and then um, everyone else you can use bash rc. And then when you go to that file, you'll see like a bunch of stuff. You just don't really need to care about them. You just scroll all the way down. And then in the bottom, you'll see these are the stuff that I've added. But you can add anything into this file, like echo hello. And then you can also add things like export path equals path dot and then temp workshop Linux workshop. This was the directory of where we saved our file. And now if I save this, enter X. I'm just gonna make sure that I had that here. And now I'm going to open a new terminal. And then you'll notice that as soon as I open a new terminal, I got this message hello. Because what happens in the bash rc and bash profile files is as soon as you open a new terminal, one of the first things it does is it runs that script. And so whatever you save in that script is going to run it. So in that script, we added a echo hello. And then we also fixed our, we also added the directory of temp Linux workshop into our path. So that's saved into our shell session. So it's not like it's technically it's not actually permanently saved into your environment variables because technically there is no such thing as like a global environment variable. It's just environment variables are always like attached to a specific terminal session, and the way to make it seem permanent is to run a script in the beginning of every shell session. Um, yeah, and the script that runs every time you open a shell is called bash rc or bash profile. Okay, so I am just going to remove the last two lines because I don't want that in my bash RC. But just to show you some of the commands that I added on my bash were a lot of exports, but for my path and stuff. But something cool that I added were a lot of aliases. So this is when I'm gonna just show you aliases really quickly. Um, actually, I'll show you here. So do you remember all of our git commands? We had like git status and all of the git commands that we added. Um, But so sometimes, like for me, I just added these aliases for myself, which means that every time I enter git s, it's going to translate into git status. So that's why um, I'll leave that here. And then if I do git s, it's going to perform the git status command for me because it's an alias. Alias, just what it means is that it takes whatever you type and then it replaces that with the alias that you set it to. So I set an alias gits equals git status, and then I also did a lot of aliases for other git commands, and I also did aliases for like cding into courses. So if I want to cd into my folder for 2xa3, I just type 2xa3 and then it goes to that course. And these are just like shortcuts for myself. And then you might, if when you're setting up things like Python, for example, you might also see like instructions for setting the alias Python to Python 3 because yeah, okay, yeah, if you can, this is another useful alias that you might come across. Now I'm gonna go through some of the next set of commands a bit fast. So this is just me teaching you a bunch of stuff, but these are just some common commands that you might see. So one command is the ps command, and this tells you what processes are running in your terminal. So these are all the processes that are running in this terminal. And remember, I told you that there's no such thing as a global thing. Everything runs off of a terminal or like a process. So this is just all the processes that are running in this terminal. But if I want to see all the terminals, all the processes running in my entire computer, I can do ps awx, and then this will show me a bunch of commands. And a lot of this doesn't mean much. I mean, for me at least, but so what this will show you like all of your processes. It will show you the command that was executed to run them. And I didn't run any of these commands myself. These are just commands that were started when the computer booted up. So when the computer starts, the kernel, the operating system starts a bunch of processes to keep your computer running. And so these are all the processes that it started, and a lot of them, you didn't know were running. And then it shows you like what user ran them. So you'll notice a lot of them, the root user ran them, and the root user is like the highest power user. Um, yeah. And then it'll also show you your process ID. And this is useful for when you want to kill a process. So when a process is stuck and you need to kill it, you would use the process ID to do that. And then it also shows you CPU time, CPU percentage, how much CPU is using, and memory, and then some other and this is like the state of the process. So there's like a whole manual about how to interpret this. And remember last time we talked about the man command. This shows you the manual page for this command. And if you want to know exactly how this works and all of the options that you can use, everything is over here. These are some examples of using some different options, and these are some more details of the options that you can have. And I think all the way in the bottom shows you how to interpret the output format. Output, yeah, process state codes. This shows you the states of the process, like if it's an interpret and uninterruptible or running, and these are just some stuff. And then in the bottom more, it shows you more details. But anyway, yeah, so this shows you like what the CPU means and CPU utilization and memory and then some other stuff. So you can find out all about the ps command by doing man ps. And then remember, when you go on man ps to exit this, you have to press q. Okay, so um I'm gonna show you. Okay, ps aux f is a useful one because it shows you the process and then also the sub processes that each process ran. So for my Firefox processes, there's like one main process and then it ran a bunch of child processes, and then it kind of shows you on this using this like what the child processes were. So you can see a lot of like child processes that were created here. But yeah. Okay, so something that is useful that you might use sometimes is for killing a process that's stuck. So I know that in like Windows you can, or Mac OS, or I know like a lot of you have used the command the process manage the task manager to kill like a stuck process. But then sometimes the task manager itself gets stuck, which is really weird. But for me in my on my computer, there's a time that my IntelliJ gets stuck. And it's like, so this is my IntelliJ, I'm opening it, and if I press cancel before it loads the assignment, then if I try to open IntelliJ again, it will not open. So I'm trying to, on my other monitor, I'm trying to open it again and it's just not opening no matter what. I try to click it a bunch of times and it's not opening because it's kind of stuck. And if for some reason it happens every time. Every time I open IntelliJ and then I cancel before it loads the project, it gets stuck. And then if I want to like use IntelliJ, then and like kill those processes that are stuck, what I can do is ps aux and then space, and then this sign over here, which is just like the vertical bar, and then grep, which I will explain more in a bit, and then idea. So IntelliJ idea, that's just a program that I want to kill. And what I do is I don't actually know which process is stuck. I think I just opened a lot. So I'm just going to copy and paste all of these process IDs. There's probably a better way to do it, but this is what I do. I just copy and paste all of this. It doesn't actually take that long. It takes like 2 seconds. Yeah, wait. Okay, there's a lot this time, but usually there's not that many. But you would kill all of the processes that are coming up here, and then it would open IntelliJ again. That's just an example of like though sometimes when I use it. So the command to kill a process is just kill and then the process ID, and you can enter as many as you want. But you just have to be careful about this because you can kill a process that's important. So don't just go on killing off like random processes. One time I did that just for fun, and then I went to the blue screen of death on Windows. So don't just kill off random processes. Usually there is security for that. You're not usually allowed to create random processes, but just to be safe, only kill the processes that you know are safe to kill. So now I only have 3 of those processes left, and now if I do that again, it's just going to show me this one. This one you can just ignore because this one just shows you the process that I just started, which was finding the processes. So you can just ignore this one. But now all the actual IntelliJ ones are closed, and if now I can open IntelliJ again. So this is what I do whenever I get a stuck program. I use this for like Discord and Microsoft Teams get stuck a lot too, so I just kill it. Okay. Okay, so let's just analyze this command for a bit. So this command, we use the symbol. This is the piping symbol. So what this pipe symbol does is the vertical line, is it takes the standard output. So it takes the output of this command. So whatever this command outputted, and then it attaches that to the input of this command on the right. So yeah, so what you can also do is, yeah, okay, so you can just do this. And then grep grep is a command that you can use to search something. So if I'm just going to go back to my temporary work uh, thing here, and then let's see what's in the file. So if I do grep hello and then my file, what that's going to do is it's going to find all instances of hello in my file here. This is a very, very useful command. Grep is very useful. Something else you can do in grep is do grep, and then before you enter the file names, I think it's -u. Oh, nope, it's not -u. It's n, I think. Yeah, and -n to get the line number. So if you have like a long file with a lot of lines, then you can just do grep -n, and then you can see the line number that it's in. Okay. And then when we did the piping thing, well, when we did the piping thing, it basically took the output, so all of the output from the PS command, and then it put that as the input of the grep command. So instead of adding 2 things over here in grep, we just add what we're looking for, and then that's why it returned, it just highlighted idea. And yeah, because PS aux on its own just returns a bunch of this, but if you're looking for a specific like command, like let's say I'm just looking for Firefox, it's going to show me all the Firefox stuff. And then you can also pipe that again to another command called WC, and that's going to show you WC means word count. So it's going to show me how many lines, how many words, and how many characters I think were in the result. So if I want to see the number of processes that have Firefox that are like Firefox related, I can do this command, and then the first one is 11. So there were like 11 Firefox processes. Yeah. Okay. And then something else you can do that with multiple commands is if you do the pipe again, and then instead of doing a command, you do xargs echo. So xargs, what it does is it takes the output of this, and instead of putting that as the input of the echo command, it puts this as the argument of the input command. So they're different. because the input is like the standard input. There are different like avenues of input, I guess, and arguments are just different. They're just different things. And if you do just like this, it's not going to work because because echo, the way echo works, is echo echo expects something else over here, and this is the argument of echo. But grep, if I do grep hello, for grep, this is the argument of grep, and this is the input of grep. This is the input, this is the argument of grep, and this is the input. For echo, this is the argument of echo. So when we do ps aux, just this, just xargs echo, this is taking the output of the whole px aux command and putting that as an argument of echo. So it's going to echo that. But if I use grep instead, I can it will put that as the input of grep. Okay. So so now I'm just so I put pwd I already showed you. It just shows you what directory you're currently on. I showed you grep, and then there's another useful one called find, and this one helps you find a file. It's like, yeah, it's just like it helps you find files in your directory. So if I was in temp and I wanted to find the my file, then I can do find, and then space, and then dot name my file. Oh, okay. This is because, okay, let me just do sudo. Okay, so you don't need to do sudo if you're not in like a root directory, but if you just do find and then space and then dot, this is a directory that you want to start the search in. So even if I did find Linux Workshop, then this would still work, because this part just shows you what directory you want to search in, and then this is just an argument that we put like name. So I want to find a file that is called my file in this directory. So that's what this is saying. And I think find is recursive by default, so we can just quickly check that. Yeah, find is recursive by default, so that means that it won't just search the it won't just search the immediate directory. It's going to search the immediate directory and then its subdirectories and then its subdirectories and then forever until it finds it. So it's not a good idea to do find on like your root directory. Your root directory is a slash. It's not a good idea to do that because it's just going to search everything. So it's good if you narrow it down. Yeah. And this is like obviously useful when you're trying to find files in in a large code base, for example, and you want to find a specific file. Another thing is tail and head. So tail reads the last n letters in a file. Let me just go back to my. Okay, so tail -1 reads the last one lines of this file. So if I had more lines in my file, like if I had this, I did tail -1 or tail -3, it's going to read the last 3 lines of this file. And then head is going to do the same thing, but for the first ones. So head and tail are very useful as well. And then if you wanted to just so tail -f, what it does is that it's going to read the last certain numbers of the file, but it's going to continuously keep reading it. So if I, on another terminal, if I add to that file in the end, like another line, and if I am just appending that to my file, it's going to show that here as well. Another line. So this is useful when if you have like a program that's continuously appending to a file. Like let's say you have a program that prints the number of, I don't know, something. It's just the program appends to the file, and it's like a long running program that runs for like an hour, and you want to continuously read updates of that file. Then you can do tail -f my file, and then every time the file is updated or like added, every time the file a new line is added to the file, you will get it right over here. So this is very useful as well, and I've used it a lot of times for different things. That's tail -f. And then to exit this, you just do Control C. Okay. And then these are some other, just like very quickly, there's history. History shows you the history of all the commands that you've entered. And then these are just some more advanced commands that you may or may not even have on your terminal, but if you do, these are useful. So ifconfig shows you your network statuses. So I won't go into deep depth into about that. And then there's IP tables. Um, if you do IP tables list, it shows you some. Yeah, I had to do sudo this. IP tables is a good one. If these are networking commands. IP tables, ifconfig. Yeah, again, I won't go into details about that. There's also netstat. But yeah, maybe next semester we might do an advanced Linux workshop that goes deep into these network commands. But for now, this is yeah. Okay, so we are almost out of time, unfortunately, because I talk way too much. Okay, we're gonna create a new bash script really quickly. And what we want to do is create 50 folders with the names folder 1, folder 2, folder 3, all the way to folder 50. So you can imagine if you do that like one by one, like manually, that's going to take forever. That's not good. So you can write a bash script for that. And so we're just going to learn some basic scripting syntax. So to do a for loop, like from 1 to 50, you do for as usual, and then you had to do two brackets, so not just one bracket, but two brackets. And then inside the brackets, you just do I equals 0. So I is your variable that you start with, and then semicolon, I less than or equal to the number you want to go up till, and then I plus plus, and then um and then you do a semicolon and write do, and then the end of your for loop is a done. And over here, I can do anything that many times. So I can just do echo, and then to access the variable I do $sign and then I, and then we'll see what this does. So I'm just gonna open a new terminal in the bottom that goes to. Okay, so I have my script over here, but I need to make it executable. So I'm just gonna do that by doing chmod. Now if I run the script, I get all the numbers that I want. And then if I want to create a folder with these numbers, what I can do is first let me just practice making a name with a folder. So I'll just do echo folder, and then I want the I over here. So I'll just do $I, like just like that. And then I save it on Vim. I can just save it without exiting. There's probably a way to do that in Nano, but yeah, that's just yeah. And then you have all the folders with the right names that you want. And now if you want to create the folders, what you can do is make dir, mkdir. And now you will just create 50 folders with that name. And before we run that script, we just wanna, let's say we wanna also add like a file in each of those folders. So we're just gonna add a file called folder, and then the same thing here, and then we're just gonna call we're just going to create a file in these folders. So to do that, we can just put the same folder name and then slash and then file, and then we save it, and then we run the script, and then now we have all of these folders. So this is an example of a very simple bash script. Bash is like just like any other program. I mean, it's like any programming languages, but it's not as like there's not a lot of like syntactic sugar, as in like you kind of like make classes, or as in Java or Python, and it's not really good for like large programs, but for like scripting things and running things that are repetitive that you do and you just want to write a script for it, is good for that. And there are for loops, there are also while loops in bash that we won't get into. um there are you can read the arguments. So if I do echo 0 1 echo 1 and then 2 here, and then I run the script, but instead this time I run it and then I write arguments here. Oh, oops. It's because here, let me just comment this out. Okay, so if I do this and then I run it, oh, okay. So now it's gonna print a hello argument because you can when you write a bash script, you can take in arguments and then you can access it from inside the script. So to access the arguments, the first argument is a one, and then the second arguments are like the numbers after one. So to access whatever I wrote over here, you can do $1, and you can also assign that to a variable. So if I do oops, if I do like number, oh my gosh, what am I doing? I am stuck on Vim. Oh, no, I'm good. I'm good. Okay. If I do num equals 1, then it's going to assign that to the variable num, and then and then I would be able to use num in I'll be able to use it in my program like that. So you can see now I am echoing num just directly by $1, and then I assigned it to a variable, and then I printed it out using this variable. Okay, cool. All right, so now we're going to go into Git branches very quickly. So I will first take some time to explain the concepts, and then we will go through some group exercises. The concept of branches in any control system is one of the most important parts of version control systems, because in a lot of times when you're working on code, you're not just going to be having like one line of versions, you're going to be having different pathways of versions. So, for example, if you're working with a group of people, you might have one mainline branch, which is kind of like your main production branch, which means that it's the one that's currently released, and you know that you've tested that branch for sure, and you know that it works. So you have one mainline branch, and then you also want to work on that code at the same time, but you don't want to edit that branch on the main line directly, because if you do, then you might make a mistake and then you'll mess up the main line, and then it'll just create a lot of errors. So what you do is, instead of working directly on the main line, you work on a separate branch. So the separate branch is like, it's still on your code base, but it's um you can still edit different files without it affecting the main line of changes. So this is like a nice diagram that shows that the mainline branch is in green and is always this one. And then you can, um, from this point in the mainline branch, you can create a new branch off of it, and then you add some changes over here. And then let's say while you're adding your changes, there are more changes that happen on the mainline branch. These two green ones over here, and then another person takes that point of the version and creates their own changes, and then meanwhile you're done your work and you want to push that to the main branch, and like you're done, you want to release it basically, so then you can merge it back to the mainline. So what this merge will do is it'll take all of your changes and put that together with the changes that were made here, so that now at this point all of your work and the mainline work is together at the same branch again. And then meanwhile someone else's work will probably want to do the same thing, they'll merge it back together at the mainline. So that's in a nutshell like what branches are, and there are different ways that people do branching. So for example, one common way that I've seen in the workplace is feature branches. So what that means, that for every feature for an app or every bug, you create a new branch for that feature. And this is useful for like medium to big companies where they have like a relatively large project, and there are a bunch of features and a bunch of bugs. And so they will create a new branch for each of these features, so that they will focus all of their work on that feature branch, and then they'll put it to the mainline. And then another workflow is each person. So this is like for use for like maybe hackathons or like a group project or like a small group of people, where each person or each developer will have their own branch, and then they'll do all of their work for their project on their own branch, and then they'll continuously be updating their own branch with the mainline branch. So there's just different ways to do it. And next semester we're running a DevOps workshop, which will go through some of these methods of Git branching and just like best workflows and best practices when doing large projects. So definitely check out the DevOps workshop series next semester. But for this one, we're just going to go through the basics of Git branches. And before we go to the group project, we're going to quickly learn the commands so that you know how to create branches. What I want everyone to do is go on their terminal, and we're going to create a new repo. This is just a local repo. First, I'm just going to delete everything that I have so far because it's a mess. And now I'm going to create a new repo called my repo. And then I'm going to cd into it, and then I'm going to initialize it as a Git repository. So that's just Git init. Make there my repo, cd my repo, and then Git init. Now that it's a Git repository, if I do Git status, we know that it's a Git repository, and we only have one branch that's master. So if I write grep branch, it's gonna show me all the branches that exist in my project, and there are none so far, so that's why it's not showing anything. But if I add a file, like any file over here, and then I just commit it. So remember to commit a file first. To do so, get status to see what's there to be committed, and then to actually commit it, you can add the file name, and then you commit it with the commit message. And now if you do git branch, it will show your branch that you're on. So you're on the master branch. And so what you can do now is, let's say I want to add a new branch. To create a new branch, what I can do is git checkout -b, and then I can name this branch Ariba. But the command is git checkout -b, and then the name of the branch. And now I created a new branch. The -b specifies that this is a new branch. So if I try to do this again, it will give me an error because this branch already exists. So the dash, yeah.
Sorry, I was just gonna say, if you do git switch, it also does the same thing, and that's like the new documentation.
Oh, really? Git switch.
Yeah, so it's git switch -c to make the.
Oh, really? A new branch?
It should be, yeah.
Oh, maybe.
That's weird.
The stupid content. Oh, Git. Wait, is that the Git manual? Git, the stupid content tracker.
It may be because you have an old version of
Yeah,
Git.
it might be you have
Yeah.
an old version of Git.
Yeah.
What version is the newest one? I have like 2.17.
Let me check mine.
I have 0.24.
0.24? Oh, 2.24?
Yeah, sorry, that's what I meant.
Yeah, never used a switch one.
Wait, sorry, what are we trying to do?
2.29.
We're just switching creating and switching to a new branch.
Oh, okay.
How do you guys switch and go to a new branch?
I just do git checkout and then the branch name.
Yeah, me
I
too.
do git switch because I'm too lazy to write checkout.
Well, actually, I do git c. It's my alias, git c. I do aliases for everything. Okay, so now that we created a new branch called Ariba, if you do git branch, you will see the branches that you've just created, and then the star and the color shows which branch you're currently on. And also, if you do git status, it will show which branch you're on. And if you do git diff and then another branch, it's going to show you the difference between the branch that you're currently on and the branch that you specified. So currently we didn't change anything on our new branch, so that's why it's showing nothing. But let's say I were to add something to my file, like my file name. Let's say I wanted to add this to the file that I just created. And now if I do git status, it's going to show you that it's changed. So, all right, so now we're going to commit this and we're going to commit it. So the double ampersand means it's just a way to combine commands. And this just means that whatever comes after this is only going to run if this one was successful. So if this command was not successful, then nothing else after this will run. This is just a small utility useful thing. Okay. And now if I switch to master, okay, so yeah, you'll notice that over here, I have a file, sorry, my file says this, and the branch that I'm currently on is Ariba. But if I check out to master, and then if I cat the file, it's not going to do anything. Even though it's just we're in the same directory and it's the same file that we're looking at, but if we just switch branches, it's going to look different. And this is because Git internally stores all of these diffs and it keeps all of them in this folder called git.git. It keeps a lot of data into this folder. And this folder is a hidden folder because it starts with a dot. And to show the hidden folders by using ls-l, you just add a to it and it will show you the hidden folders. And then if you do this, you can see all of the data that it stores in this repo. So there's a lot of data. So yeah, you wouldn't really need to edit any of this unless the only thing you might want to edit, we need to edit in the future is the config and maybe head. Yeah, but everything else Git just takes care of it itself, and this is where it saves all the data. So if you accidentally like delete the folder .git, and then if you try doing git status, it's gonna remove all the data that you had. So never do this. Now I just deleted all of the data that I just had, and if I do get my cat my file, I just happened to be on the branch Ariba, so that's why this file was right, but all of my like data of Git was gone. I'm just gonna add everything back again. Okay. Yeah. All right. So now let's say I have this change here and I just create a new file and so now in my Ariba branch I have 2 files. Just doing this faster now. Okay, I have 2 files and if I go to master, okay, oops. Okay. So okay, so my Ariba branch has 2 files and my master branch only has 1 file. To look at these differences, I can go on the Ariba branch and do git diff and then master. And then this will show you the changes over here. And then if I want to merge, if I'm ready with the changes that I made in my branch and I want to merge it to master, I can check out to the master branch. And then I need to merge my branch Ariba into master. So I can do git merge and then Ariba. And now it's going to take all the changes from my branch and then merge it together so that now after running this command, my branch that I created is up to date with master. Yes. No, wait. No. This master branch is up to date with Ariba, not the other. It's actually, there's a difference. But yeah. Okay, so with that being said, I'm just gonna show you one last thing. So now if I did it the other way around, so let's say I add a file in the main branch master, and then if I just commit this, and then if I check out to my branch here, if I do git diff, if I do git status, and it will show me nothing, but if I do git diff master, it's going to show me that there's a deleted file, but it's just saying that there's an extra file in the master branch that's not in this branch. And if I want, so basically right now my branch Ariba, my branch master has one additional file that this branch doesn't have, And if I want this branch to take those latest edits from master, what I can do is rebase. So git rebase from master. So what that's gonna do is take all the changes that I ever made on this branch is going to take those changes and fast forward them to whatever's currently up to date on master. So yeah, so if I do git rebase, it basically rewinds the head and replaces my work on top of it. So all the changes that I made on Ariba, it just like takes that in one place, and then it takes whatever is currently in master right now, like so all the latest update changes, and then all the changes that I had it on my Ariba branch is going to apply that to the new master, not the original one. Because remember, you look at this chart, and when I first created a new branch over here, I created a new branch based off of this master, like this mainline over here. But while I was adding more stuff, there were more changes that were added to mainline. But these two little blobs over here weren't actually part of my branch because when I merged from when I checked out from master, I checked out at this point. So I only have these changes. But if I want to add these changes as well, what git rebase does is it takes this line over here and it basically puts that line over here. So just imagine like crossing this line out and putting this line over here, where it's going to take all my changes and put it after the stuff from mainline. And another way that you can take these changes and put them in your branch if you just do the merge command. So if you do git merge this, then it would take this line and put it over here. So it's just two different ways of doing it. I always use git rebase, just personal preference, I guess. But you can also do git merge and put all of this stuff into here. So put a line that goes here to here, and then you can merge it back into mainline. Or what we did with rebase, take this line and put it here. Okay, so yeah. So okay, that was that. Now we're going to work on the project. So for this project, what we're going to do is we're all going to get into groups of 2 or 3. So I want everyone to go on Discord and just click a group of 5 because we want some of the mentors to join in too, just to leave some room. So join a group of 5, and when you join, if there's already some existing groups that have only 1 or 2 people, you can join that group as well. But join a group of 2 or 3. And what we're going to do is we have some tasks, and so on our Git repo over here, there's the main branch and there's all of these branches. So we're gonna assign each group a number, and then what each group needs to do is they need to work on this branch, and um, so okay, so what you need to do is check out that your group's branch on your local computer, and then on top of this branch, create a new individual branch and add a change, um, and then merge it back to the group branch. So then make sure that all 3 of you have your changes merged into your group's branch. And then once you're done that, then as an entire team, we can merge all these group branches back to main so that we have all of the group changes into the main branch. So the first step is to go into your groups, and then the second step is to create check once you get your group assignments. First, you'll be in like the master branch in your local repository, and then you want to go into your group branch. So to do that, you do git checkout and then the number that you want, like git checkout group 01. And then for me, it's showing me error because I'm the git repo, but I'll show you how to do that here. So if I do git clone and then this here, git clone this, and then cloning into that, and now I'm just doing Linux Workshop. Now if I do git status is here. If I do git branch, also just notice if you do git branch, it only shows one branch because the git branch only shows the branches that are available on your computer, not like the entire repository. But if I want to check out into group 01, I just do git checkout group 01. And now it's going to say branch group 01 to set all this stuff, and now you're on the branch that's 01. And now when you're in that group branch, what I want you all to do, each individual is going to create a new branch called git checkup b. So this is how you create a new branch. You're going to create a new branch called group01 and then dash and then your name. So you create your own individual branch. And once you create that, you've only created that branch on your local computer, but you need to push that branch into GitHub. So to do that, you just do git push. But once you do git push, it's going to show you this error. And it's going to say that you have a branch git01 Ariba, but only locally. You don't have it on GitHub. So you just need to create the branch get on the remote, so like on GitHub. So you literally just take this command that it suggests and you just copy and paste that, and now you log into GitHub. And now if you go on GitHub, there is going to be a new branch that you just created, group01 Ariba. So now you should have a branch that's that, and now you just want to create a new folder in your group folder called your name. And what you're going to do is merge that into, you want to first commit it. So git add. I'll go slower tomorrow, but yeah, git add and then git commit. Message. And then we're gonna git push. So if I just commit it, it's only gonna save it locally, but I have to push just so the changes are reflected on GitHub. And now what we're going to do, once each individual has their own change pushed to the GitHub, each group is going to try to merge their individual changes into the group01 branch. So right now I have these 3 branches, and right now the changes that I made are only in my individual branch, but my group's goal is to merge my changes and the other group member changes into group01. So everyone, so yeah. So the best way to go about this would be to have only one person do the merge. So one of you, maybe you guys can share screens, but one of you needs to go and check out into the group branch, and then after all 3 of you have pushed your branches onto GitHub, what you're gonna do is just git merge. And make sure you're on this branch over here, group01, and then you're gonna merge group01 dash Ariba, and then you're gonna merge to group01 dash whatever your other team's names are, and that's all you do to merge the branches, your individual branches into your group branch. But when you merge, you still have to push it, because when you merge, you're just merging locally, and then when you push it, and then so once you push it, now when you refresh and go to your branch group01, or which one was it, group01, then it's going to show you on the group01 folder, it's going to show you the file that I just had. And then it's also showing it to you in group01 Ariba. So that's how you do that in your groups. And now I guess you guys can try to figure out how to merge your group branch into the main branch. Well, actually, something else that I wanted you guys to practice with is for now, all of individuals just create a new file with their name, but the other exercise would be to edit the group file. So this file over here, everyone add a line to it, and then save that in, and everyone add a line to the same file, and then make that merge into group01. And this is going to be more complicated because this is going to create merge conflicts, and then we're going to learn how to solve merge conflicts. So I taught you guys how to solve merge conflict last time, so let's see if you guys can remember how to do that, and we'll come around and help you guys. Okay, and then after that, the last exercise is, if you have time, is to merge all of the group branches into the main branch. So we'll have probably each one group member go and check out to master, and then merge their group branches into master, and then try to push, and then it should probably work. And yeah, we'll just walk around and solve issues.